Okay, today I'm going to be talking about the frequency response curve and what it is and what it does. So it is a graph that shows frequency and amplitude attenuation, and it's important to us as EEG techs because we use filters during our studies. The filters that we use help filter out things that we don't want to see, for example 60 hertz artifact and stuff like that. But the filters do not only affect the things that we don't want to see, they also affect things that we do want to see, like abnormalities in the brain. So the frequency response curve makes it possible for us to calculate how the filters have affected the frequencies and waves that we're actually seeing. So on the graph, the y-axis shows the amplitude in percent, and the x-axis shows frequency in hertz. So the one that I drew looks like this, and the top one is going to be the low frequency filters, and the bottom one is the high frequency filters. And after looking at the notes and listening in on the Zoom meeting, I have a better understanding of how to calculate it when I'm given a question. So it's definitely a lot easier in that sense. So for example, if you wanted to know how a certain wave is affected, like the 1.0 wave at 1 hertz, you would move your finger over to 1 hertz, and then you would move up until it crosses with that line. And as you can see here, it is crossing at this yellow line, and that yellow line is 70%. So that means that that wave can be seen at 70% of its original form, which means in opposite terms, it's attenuated by 30%, so it's changed and kind of different 30% of the actual wave. So it's definitely important for us to be able to calculate these things, because if waves are being changed because of the filters that we're using, it would be a lot harder to kind of find abnormalities and be able to differentiate them, because they look different than they actually are because of the filters. So that's it. That's all I got. Thank you.